According to Section 250.122c3 of the National Electrical Code, the grounding terminals in switch boxes and in the air conditioning unit's cabinet are generally rated for 90 degrees Celsius termination. This is an important consideration when determining the appropriate size of the equipment grounding conductor, often abbreviated as EGC. Let's consider a scenario with two side-by-side air conditioning units to illustrate this point. The first air conditioning unit has a minimum circuit ampacity, or MACA, of 18.9 amps and a maximum overcurrent protective device, or OCPT, rating of 30 amps. Based on these specifications, a 14 American wire gauge, or AWG, copper conductor would be suitable for both the circuit conductors and the equipment grounding conductor. Now, let's examine the second air conditioning unit. This unit has an MCA of 21.6 amps and a maximum OCPT rating of 30 amps. In this case, the circuit conductors would need to be a minimum of 12 AWG copper to handle the higher ampacity. The question then arises, can we still use a 14 AWG equipment grounding conductor, even though the circuit conductors are 12 AWG? The answer is yes, provided the grounding terminals are rated for 90 degrees Celsius termination. Section 250.122b generally requires the equipment grounding conductor to be sized according to Table 250.122, which correlates the size of the overcurrent protective device with the required size of the EGC. However, Section 250.122c provides some exceptions to this general rule. Specifically, Section 250.122c3 addresses situations where conductors are adjusted or increased in size to compensate for voltage drop. It states that if the circuit conductors are increased in size for voltage drop, the equipment grounding conductor shall be increased proportionally according to the circular mil area of the ungrounded conductors. However, there is an exception to this exception if the equipment grounding conductors are run with the circuit conductors in a cable tray or in raceways. The equipment grounding conductor size shall be based on the rating of the overcurrent protective device as specified in Table 250.122. If we were in a situation where we increased conductor size for voltage drop, consider a situation where the ungrounded conductors are increased from 12 AWG to 10 AWG to address voltage drop. The circular mil area of 12 AWG copper is 6,530 circular mils, while the circular mil area of 10 AWG copper is 10,380 circular mils. This represents an increase of approximately 59% in the circular mil area. Therefore, the equipment grounding conductor would need to be increased proportionally. If the original equipment grounding conductor was 14 AWG copper, which has a circular mil area of 4,110 circular mils, the increased size would be calculated as follows: 4,110 circular mils multiplied by 1.59, resulting in approximately 6,535 circular mils. This would require an equipment grounding conductor larger than 12 AWG copper, which has a circular mil area of 6,530 circular mils. A 10 AWG copper EGC with its 10,380 circular mils would be sufficient. In our specific scenario with the air conditioning units, we are not increasing the conductor size to compensate for voltage drop. We are simply using 12 AWG conductors for the second unit because its MCA requires it. Therefore, Section 250.122c3 does not apply in this instance, and the 14 AWG equipment grounding conductor is permitted for both air conditioning units, assuming the grounding terminals are indeed rated for 90 degrees Celsius. It is crucial to verify the temperature rating of the grounding terminals in the switch boxes and the air conditioning units cabinets. This information is typically found on the equipment labeling or in the manufacturer's specifications. If the terminals are not rated for 90 degrees Celsius, then you would need to size the equipment grounding conductor based on the termination temperature rating of the equipment, which could potentially require a larger EGC. However, in most modern electrical equipment, the grounding terminals are designed and rated for 90 degrees Celsius termination, allowing for the use of a smaller equipment grounding conductor as permitted by Section 250.122c3. Always consult the latest edition of the National Electrical Code, as well as any applicable local codes and regulations to ensure compliance with all requirements. When dealing with electrical wiring, it is always best to err on the side of caution and consult with a qualified electrician if you have any doubts or concerns. Electrical work can be dangerous, and it is essential to follow all safety precautions to protect yourself and others from harm. Understanding the nuances of equipment, grounding conductors, and termination temperature ratings is crucial for ensuring the safe and reliable operation of electrical systems. By adhering to the guidelines and regulations outlined in the National Electrical Code, you can minimize the risk of electrical hazards and maintain a safe electrical environment.